Here video. This is on Cape IT Unit 2. I hope you learned something. Normalization is basically what you do when you have a desk. When you have a desk, you just put your computer in one place, you just put your books in the next place, you just put your water in the next place, you just put your this in the next place, and you put that, and you just put this, all sorts of stuff in different places. Because you want to make sure that when you need to get something, you're going to get it and it's not mixed up. When you have a really messy desk, it's not normalized. So normalization is to efficiently organize data in a database. So the two goals would be to eliminate redundancies. So you don't want to store the same data in one table, and ensuring that the dependencies make sense. So making sure the relationships are correct. They both do something. They reduce the amount of space in a database, and it makes it more, efficient. So when we're doing normalization, our goal is to get it in a way that we don't have issues with that we do have issues with the data that makes it inconsistent. So different types of normal forms. First normal form is unnormalized, or UNF. Just give me 1 second, please. Right, sorry about that. Yeah. Okay. So normalization requires you to so the first type of normal form is unnormalized, or UNF. So you might have repeated data. Things may not be atomic. Atomic means that it's not in one spot, and it doesn't have a primary key, and it might be repeating fields. So let's look at an example of unnormalized data. You have an ID number here, fan ID, first name, surname, band ID, email. But you realize inside here you have 4 email, you have 2 email addresses. You have this one and you have that one. That means it's not atomic. Atomic means it only supposed to have 1 piece of data per field, but this has 2 pieces of data. So you have a problem. So unnormalized data usually has that, or they're repeated pieces of data. So let's say you have a person who's doing, their name is student 1. They're doing ComSci, the HOD is A, and the phone number of the HOD is that. ComSci. So everybody knows that the HOD is A. Everybody knows that the phone number is that, but each time you list ComSci, you're going to list the HOD and the phone number. So you have a problem. So if you update the phone number, it'll be updated has to be updated in 3 locations. It's not efficient. So if you wanted to change the department head, or the head of department of ComSci, you're going to have to update the phone number here, here, and here. That's why it's called an update anomaly. An update anomaly is going to cause that problem. So when you have unnormalized data, you have different problems that are going to bounce up. So this thing here will be one problem, because if you want to search for a particular email for this person, you search for this email, you're not going to find it, because this whole thing here is the actual piece of data. So what you want to do is, normalization is going to reduce the unnecessary repetitions found in the database. So the unnecessary repetitions would be that instead of having the ComSci department and the HOD information and the phone number repeating 3 times, you'll create 2 tables, one for student, one for department. So the student will have an ID, and then that student will be doing ComSci, cool. How do you get the information about ComSci? You relate it to this department here, and then you will get the phone number and the name of the HOD. So once you update this phone number here, it's going to naturally cascade onto this one, and that one. So normalization is basically breaking tables up so that it's more efficient, so you don't have anomalies or you don't have problems when you create it. So the problem that I have here, which is if you try to change your phone number, you have to do it 3 times. In this one here, if you change your phone number once, it will apply to this one, and that one, because there is a relationship between department and department ID. That is the concept of normalization. The goal is to reduce those kinds of errors. Okay, good. So now we're going into the different types of normal forms, and each normal form, the goal is to get it to be able to reduce the amount of errors and the amount of anomalies. Whether you get it in first normal form, second normal form, or third normal form, doesn't matter, because you could do something, you could make a table into first normal form and it meets second and third one time. You could get it into first, then you have to do more to get it into second, then you have to do more to get it into third. By the end of the day, you want to stop all the anomalies in the database, which I'll get to at the end, right? So let me go to the first normal form. First normal form, you mustn't have repeated or similar data, which is the same thing I just showed you with the telephone numbers. Data cannot be broken down any further, meaning it's atomic, so you have one field and that one field has the information. Each row has a primary key, it should have a primary key, and each field has a name. So it will look something like this. Problem here is that somebody have a last name as Smith, but then everybody's last name is Smith. Peter, Mary, and John have a last name as Smith. So you'll never be able to find information about Peter, Mary, or John because all of them are one piece of data. So they're not going to make any sense. So you're going to have to try to put these names into their own field. So Peter will get its own record, Mary, John will get their own record, and then each one of them will have Smith there. Right? So they're all given their own record because this data has now become atomic. Right? Once it becomes atomic, means it's only that data fitting in that field alone. This one here, we have a problem because the data is not atomic for the weight field. Some of them have pounds, some of them have kilograms. So in order to make it atomic, we have to create a new field, which would be the weight and the unit. That way, you could check for people whose weight is in pounds. You could check for people whose weight is in kilograms, because when you want to do a query, because the whole point of the database is to be able to do queries, you'll be able to look for a particular unit inside the query. Right, this one is our next first normal form problem. Data is not atomic again because you have part 1, 2, and 3 inside here. So you're going to have an issue. So in order to break it up, you have to remove the repeated fields. But there's still a problem because you have part 1, part 2, and part 3. All of these are still a part of a subset called parts. So instead of having part 1, part 2, and part 3, because you're going to end up having an empty space here. Empty spaces here are going to make your queries go crazy because they're going to return zeros. So you don't want to have empty spaces in your database. So what you have to do is, for this one to get to first normal form, you're going to have to give it its own record, and then eventually when you get to second normal form, you're going to have to split it. Right? So first normal form is, these are different types of things that could happen with first normal form problems. When I get to the work answers, you will see how each one of them could pan out. Second normal form is all non-key attributes must depend on every part of the primary key or candidate key. Now, this is where candidate key comes in. Candidate key is, remember what I told you, candidate key is when you join two fields to make a candidate key. The real thing you have to do is ask yourself the question, if A changes, will B change also? So let's look at this. The tables in first normal form because they relate to each other and they kind of don't really have any issues, and so it makes sense. if we were to get this in second normal form, we'll have to ask the question, is this field sales office and office number, are these related to the employee ID? Sales office and office number actually relate to the salesperson. So therefore, these two fields don't relate to the primary key. The only thing that relates to the primary key here is salesperson. So that's a problem there. So we're in first normal form, but we're not in second normal form because every all the keys must relate to the primary key. And in this one, we have a composite key, which is customer ID and employee ID. They make up one special key. Now you have to ask yourself, is the customer name, customer city, and postal code, do those relate to the employee ID? No, they don't. This actually relates to the customer ID only. So in order for this to make sense, I have to break up the tables. So I'm going to take the sales table, and I'm going to take the customer table and break them up. So the customer table is going to have customer ID, meaning the customer ID must relate to the customer name, city, and postal code. If the question here asks itself, if this changes, if customer ID changes, does this change? Yes. Does this change? Yes. And does this change? Yes. If the customer ID changes here, does this change? Yes. So now the sales table, I'll split it into employee ID, which will be salesperson, and then I'll have sales office ID. If the employee ID changes, will the salesperson change? Yes. Will the sales office change? Yes, because they're all linked to this employee ID. And then the sales office have a sales office ID. If the sales office ID changes, will the sales office change? Yes. Will the office number change? Yes, because they're all related to this. So each non-key attribute will be anything that is not the primary key, which will be like these here. They must be related to the primary key. Meaning if the primary key changes, the non-key attribute is going to change. Third normal form now. Sometimes you have to create new tables to introduce some ID in order to have primary key that relates, right? So let's go to third normal form. It meets the requirements of second normal form, but no non-key attributes must have a transitive dependence on the primary key. Transitive dependence means that it have a kind of cascading. So you are dependent on your mother, and your mother is dependent on your grandmother, right? But all in the same table. So you can't have a dependency on your grandmother through your mother. If you're gonna have a dependency on your grandmother, you have to have the dependency on your grandmother alone. So watch the concept now. So this same table that we had here, customer postal code really does not depend on the customer ID totally. So like if the customer ID changes, the postal code doesn't really depend on the customer ID. What the postal code really depends on is the city. So yes, it is in second normal form because it does depend on customer ID. If the customer ID changes, it does change, but it only changes because the customer ID changes customer city, and then customer city is going to change the postal code. So that's why you call that transitive dependence. Transitive dependence means that the primary key will change one thing, and when the primary key changes that one thing, so the customer ID is going to change this, and then the customer ID is going to change this, and then when this changes, then these things will change, and then that will change. Transitive dependence means that you want to get this postal code to depend on the city alone. So what you're going to do is you're going to create a relationship where postal code and city will be separate from each other, and therefore you create a relationship between postal code and the customer, so that this change here will only be taking place there. So third normal form is basically making every table self-sufficient. Once you make the table self-sufficient, then everything is okay. So now you have to ask yourself, if this changes, does it directly change that? Yes. Does it directly change that? Yes. There is no transitive dependency here. If the postal code changes, does it directly change that? Good. If this changes, does it directly change that? Yes. If this changes, does it directly change that? Yes. And does it directly change that? Yes. If this changes, does it directly change that and directly change that? Good. In second normal form, you don't have those direct changes. Second normal form, you have cascading changes. things could change because other things have been changed. And those are the normal forms. So first normal form rules, data is atomic, no repeating groups of data. Cool, 2 marks. Second normal form, when you're in first normal form and all of its non-key attributes are dependent on the primary key. Third normal form is when you don't have any transitive dependencies. Transitive dependencies meaning they all cascade. But it's very possible for you to start with an unnormalized table and then you split that table once. When you split that table once, you might tick off first, second, and third at the same time. It's very possible that could happen. It's possible that you could have a table, you split the table into 2, and you get it into second normal form, but then you have to split the next table into the next 2 in order to get into third normal form. It's possible. But a lot of the times when you make one split, the tables are done. Where the theory questions will usually come in will be like here. What are the benefits of normalization? They might ask you multiple choice questions like you don't have redundant data, you have less data to search through, so queries run much faster. There's no data duplication, so there's a less chance of having errors. And once a change is made, it's immediately applied to all the relationships. So the downfalls of normalization, splitting, making data atomic could be unnecessary at some time. So if you have like a phone number 868 7772222, if you split this up into number, then you split this up into area, then you split this up into country, then you might be making the data a little too atomic and it'll be kind of hard to search for a number. So you might just want to make sure that you keep the number together. Right? So you can end up with too much tables and it makes it complex. So if you have too many tables, you will have an issue. So you want to get a kind of balance of the right amount of tables. And with more tables, queries could become very complex because you have to now type very intense queries now. Right? So what the whole of normalization is trying to prevent is something called anomalies. So the anomalies are update anomalies, delete anomalies, and insert anomalies. So let me show you what the first anomaly is. Update anomaly is this. When you have more instances of duplicated data, you would have to change the address of plenty of people. So let me say you have Jones here, right? If you want to change the address of Jones, you're going to have to type over Edinburgh here and Edinburgh there. That's an update anomaly because you may update this one, but you will forget to update that one. So when you do a search in the database to see where Jones is living, you might change this one from Edinburgh to London, right? And when you do a search, you will get back Jones living in London and living in Edinburgh, because when you updated the record, you only updated one of them. What will happen is that if you split these two into student name, split it into course and student information, it will be able to update faster because you will be able to just change the address once and it will match back to that particular student number and you wouldn't have an issue. A delete anomaly now would be if you do a query and you say delete Jones from the database, or for example, if you delete student S30, right? And you delete student S30 from the database, you'll delete them from the maths course. But if you delete them from here, then you're also supposed to delete them from the computing course. So basically, this person will still be registered as doing the computing course because you deleted only one record. If the table was split, however, and it just delete S30 once, it will take them out of computing and take them out of math at the same time. So that is a delete anomaly, meaning once the tables are normalized, you delete in one place and everything will cascade. Update anomaly, you update in one place and everything will cascade. And then an insert anomaly is when you try to insert something into the database without the presence of other attributes. For example, you can't add a new course unless we have at least one student enrolled in the course. So let's say we decide, all right, we're going to create a new course called English. It will tell you, well, we need to add a student to this course. If we don't have students in that course, then we can't create the course because it will tell us we have a problem because we do have all these other fields filled out. You got to make sure you fill out all the fields here. So if the tables were split, you could create a course number called 9324 and call it English. And that would relate to the student numbers that choose that course. So you can't insert something in a record because you have to fill out all the spaces in your record. And that's normalization. Right, I have some worked examples to work out the normalization. Thanks for watching the theory video. If you learned something, give it a like, give it a share, subscribe, do whatever you have to do. And if you want practical applications of the things, feel free to check out any of my classes. You can find them on my website at makeITsimpleTT.com. I have classes for all different subjects from CSEC IT, CAPE IT, CAPE Computer Science, and many different tutorial videos I could find on this channel. So, thank you very much, and look out for the next video that is here or here, because I have all the theory videos for all the subjects.